This Nano is running the Blink program, but what happens if I decide, for whatever reason, to attach a motor to it? As the motor comes on, my Arduino resets. But why is that? It feels like a software issue, but it's not. It's a power issue. If you've ever used a motor, a relay solenoid fan, you've likely encountered this. It reset, it glitches, it freaks out. People will end up blaming the code, but the problem is the hardware itself. When the motor starts, a huge surge of current happens. That current flows through the supply and the wiring. Every wire has its own resistance, and high current times resistance will equal a voltage drop. Now, the reset is never guaranteed, as I've connected this and my Arduino didn't reset. But why is that? That's because load. If I stop this, we've noticed that the code itself has stopped, letting it go, and it resumes. Adding resistance dramatically increases the amount of current being pulled by the motor. Let's see what our voltage ends up looking like. Connecting our probe, we'll see about 4.8 volts. Connecting the motor, and we immediately see a hard dip in the voltage. Applying resistance to the shaft, and we'll see an even greater dip in the voltage. While this is annoying, this dip, this brownout threshold, is not a bug, it's protection for the chip itself. Ground is not a magic infinite sink, it's a wire with resistance. When motor current spikes, the ground line rises slightly. To the microcontroller, that looks like the reference has moved. That's ground bouncing. Motors, like this one, are inductors. Inductors resist changing currents. When you turn off the motor, the current tries to keep following. That creates a voltage spike, and that spike goes wherever it can. The most important rule for dealing with microcontrollers and motors is never run a motor directly from a microcontroller pin or shared voltage. Not even a tiny one. If you've ever dealt with drones, building your own drones, these motors will be very familiar with you. Connect 4 of them straight to your Arduino, and it will reset a bunch of times, and it will make you suffer. We're going to need a motor driving stage. We're going to need a transistor, a MOSFET, or a driver IC. I would like to introduce you to a very close personal friend and the solution to today's problem, the ULN 2803A. Now we're going to have to set up the ULN 2803A. First, let's connect our ground pin over to our universal ground. I'll take our COM pin and I'll bring it over to pin 50 for right now. We'll connect to that in just a moment. Now, for this to work, we're going to need 2 separate supplies. So for the first supply, I have an Arduino Uno, and for our motor supply, I have this adjustable power supply. It's something cheap, very easy to understand, and easy to use. I'm going to connect the positive end to 50 and the negative end to 52. And then I'm going to have to come all the way from 52 to the universal ground. Now, for our motor to work, I'm going to have to connect the power to our motor power supply rail. And the negative side is going to come to out number 1. And from the Arduino Uno, I'm declaring D3 as the motor control pin, and that will come into pin number 1 on our ULN. The ULN will take a tiny logic signal and switch real current, and it keeps the motor current out of the microcontroller's ground path. These Darlington transistors, they do drop more voltage than MOSFETs, which is fine for smaller motors, but it's not going to be ideal for anything larger. Now, for added protection, I'm going to take a Flyback diode. This diode is going to keep the motor current a safe loop when the switch turns off. reverse this diode and you will short the power supply. So don't do that. The striped, and I'm going to put into a 50 with all of our power supply. Then I'm going to jumper from the other end into the ground path of the motor. This will create a safe loop so voltage doesn't fly backwards, it only goes in one direction. Then we can take this bulk capacitor, a 470 microfarad capacitor, and they'll go between B50 and B52, which are our power supply in and out. Be sure to mind the stripe on these or they will explode on you. This will handle big surges when the motor starts. Then we have this tiny little logic capacitor. It's a 0.1 microfarad ceramic capacitor, and this is just going to go between the ground and the negative on the Arduino. If I can put it in. Made it mad briefly for a second there. The ceramic is for speed, the electrolytic is for energy. This little guy is going to handle the fast noise, the stuff that the electrolytic can't react to. I'm also changing the blink code to also trigger pin D3 whenever the LED blinks. This will activate our motor with our power supply, or at least it should. Also, this jumper between the Arduino Uno ground and over here to A52 is very important. The motor current returns to the supplies through its own path, so the logic ground stays clean. That keeps this from resetting. Now, plugging everything in, we immediately see our motor starts working, and our Arduino Nano never reset. It doesn't fade, it doesn't flicker. It works perfectly fine. This is the exact same motor, same code, minus the fact that I had to trigger D3, but that's about the same as triggering an LED. It's the same load, but now there's no resets. It was never random. It was always the power's integrity. There are 3 main causes to the Arduino Nano's resets, and those are voltage dip, ground bouncing, inductive kicks. 3 fixes: driver stage, clamp path, local capacitors, and sane wire. I know this looks a little insane in terms of wiring, but it gets to be a bit more of a mess than this. So sane wiring. Once you see it, you'll never blame the code again. You'll go, I hate this. Just please work this time. Thanks for joining me, and I hope this has helped you.